Let's take a quick look at some of the resources that we get from the seafloor. One resource that we get includes petroleum, gas and oil. You've probably seen oil rigs like this off the coast of Southern California, especially if you've gone up as far north as Ventura and Santa Barbara. Petroleum that is found offshore on the continental shelves is made primarily from organic rich muds on the shelves. The organic material is basically plankton, phytoplankton, zooplankton, and it can also be bacteria and algae. What happens is that these little microscopic organisms fall to the seafloor and then they get buried and they form sort of an organic rich mud. And the water has to be pretty still for this to happen. And they also have to be buried pretty quickly. And so here's an example of some layers that were buried pretty quickly that are organic rich. And this is actually called a source rock. It's the source of the organic material that's going to give us the petroleum and the hydrocarbons. Down here, the temperature and pressure increases, and the mud gets turned into a mudstone or a shale, which is a rock. Eventually, that heat drives some of the material, the organic material, out of the rock as a liquid or a gas. And that liquid is oil and the gas is natural gas. It moves its way upward through pores or spaces in the overlying material because oil is less dense than water. If there aren't any what we call traps, geologic traps, that oil will simply make it to the surface and seep out. And if you've been to the beach in Ventura, you know there are oil seeps there. Sometimes it's in the form of tar. I've gotten tar on my foot, and it's very, very difficult to get out. However, if there's a geologic trap, such as a fold like this, where the oil can build up in a pocket or some other type of trap, then we can go in with a drilling rig and we can get that oil out. And that's what's shown here, a rig that's been placed on the continental shelf that's tapping into that oil. And here's an example of what that looks like. So we get a lot of petroleum from the continental shelves. And that's one type of energy resource. Another type of energy resource is something called a gas hydrate. And this is also mainly found in the continental shelves. This is a really unusual thing because it's methane, but it's frozen methane. And here's somebody holding a piece. You can see it's dripping below their hands like liquid, but it's on fire above their hands because the gas that it's giving off is methane, which can burn. Here's a piece of gas hydrate, again, frozen methane basically, that's mixed in with a bunch of mud. So it's very difficult to remove economically from the seafloor because it's mixed in with this mud, but there's lots of it down there. This is just showing a map of the northern part of Alaska where they're showing the limit of gas hydrate stability zone. In other words, an area where the gas hydrates are stable and not just going to evaporate into the air. So these are ice-like crystals that form in deep sea sediment. And they combine gases like methane and even carbon dioxide and ethane combine with water and freeze under low temperatures and moderate pressure. Like I said, methane could be a good energy resource because it does produce energy that we can use. We can burn it and produce energy. However, methane is also a greenhouse gas, so we have to be careful that it doesn't get released into the environment in large quantities because that could really affect our global temperature. Also, when we've gone down to look at gas hydrate deposits like this, we've seen very unusual communities of organisms that live where these conditions are present. Here's an interesting picture from a dive that was performed in 2007 in the Gulf of Mexico. And what you can see here are actual bubbles of methane surrounded by gas hydrate that are bubbling out. And this was a little 1-minute video. These things were actually seeping out and then kind of popping and floating upward out of the picture. And so this is the methane being released, and this kind of yellowish looking stuff is the frozen gas hydrate. So that's another resource that we have out in the oceans. Other resources that we have include things that we can collect from the seafloor, including sand and gravel, which we use for building materials and construction. And sometimes we have deposits and concentrations of tin and gold and other metals. Evaporative salts are certainly concentrated in the oceans, and you can see here that there's a large operation where they're taking salt. This is all salt down here, and they're scooping it up for commercial use. Phosphorate is another thing that we collect from the seafloor. And then there's this thing called manganese. That's a very unusual thing that we find on the seafloor. Manganese nodules are these round nodules that are found occasionally on the seafloor grouped together. So for example, this is a rather old photo and they've used some sort of scooper to collect a whole bunch of nodules that were all together. And here's a picture that was taken several miles below the sea surface of manganese nodules. Nobody really understands how these things form. Some people actually think there might be some sort of symbiotic relationship with some animal that rotates them because they seem to have a concentric sense to them. If you look here, there's two modules together that are cut in half with a diamond tip saw, so you can see very clearly the internal structure. They each seem to have some sort of nucleus, and then it looks like they are concentrically layered with the manganese. So very puzzling, but manganese is a very important element in our daily lives. It's used in steel production, used for fertilizers and ceramics. It's used for paint pigment, for a black-brown paint, and it's also used in dry cell batteries. So manganese nodules are another thing that comes from the seafloor. These are all under the category of rock and mineral resources, not necessarily energy resources. For our next unit, we're going to move away from the seafloor and take a look at the ocean's water.